Hello, this is Brett from SurvivalComms, and today on the bench we have the Schumacher Mighty Mite booster pack. Now these were primarily marketed as a way to jumpstart your car, and they just use a gel cell battery. They have an internal charger, and they have a typical 12-volt cigarette lighter plug on the side of it. And I've had this one here for about 12 years now, and I've replaced the battery internal to it in the past, and as you can see here, it shows it needs to be recharged. But the problem I'm having is that it says it's charged all the time. So what we're going to do today is we're going to take this apart and see if that is the problem, that the cell's bad inside of it. I used one of these quite a bit for radio. I actually ran a PDR 3500 repeater for an exercise one time off of this particular pack right here for the entire exercise, and it worked admirably in that capacity. Oftentimes you'll find these things at garage sales for next to nothing, maybe $1 or $2, or you'll find them being discarded or disposed of, and they're really not that difficult to repair. Okay, first thing we do is we just take the two DC output clamps and lay those to the side, and we have a variety of Phillips headed screws that are holding this assembly together. Using a number 2 screwdriver, we'll go ahead and remove these screws. Okay, once we've removed the cornucopia of screws that is holding these two halves together, we can go ahead and pull it apart. See, it comes off here pretty easily. And we can kind of see what's inside. Let me see if I can get something that gets a better view here. You can see there's your gel cell battery, and I've replaced that in the past, probably about 3 years ago. There's your wall wart that powers your charger. There's your cigarette lighter plug, and all that ties into this circuit breaker back here. Okay, checking our battery here, we see our battery's at 12 volts, which, I mean, it's acceptable. It's not like completely dead. You'll see these things on occasion, these gel cell batteries, when they're really shot, they'll be down like 8, 10 volts, something like that. What we'll do is just use an 8mm nut driver and wrench, and we'll go ahead and disconnect our battery. We've removed our battery, and before we go crazy and purchase a new battery, we're actually going to ascertain that this battery itself is defective, if it is in fact defective. And how we're doing that is we're going to go ahead and charge it with a charger that's external to the booster pack itself. And I have this little 1 amp charger here that I use for gel cells, and this is a great little charger. It brings it up to about 14.7 volts and then cuts itself off and goes into a float, and it floats at about 13.8, so it's a really nice little charger. Now we've squeezed about as much power off the charger into this battery as we want to, so we're going to go ahead and disconnect our charger, and we're going to do a DIY load test. And what we're going to use for that is these are 30 ohm wire wound resistors, and they can take a lot of heat, of course, and you're going to put this across the terminals. Now, one of these by itself draws about a half an amp of current. Now, with resistors, when we parallel them, which we'll just take this and clip this back to here, and now it's going to draw close to an amp. And what we do is we measure how long it takes to discharge the battery, and its capacity being a 12 amp hour battery means theoretically that it should take 12 hours to drain the battery. Now when you're doing something like this, these will get hot in use, so it's important to make sure they have a good amount of ventilation. We've got our ammeter set up, and we'll go ahead and take our resistor and clip it on there, and we can see right now we're about 850 milliamps of draw, which is good. We're not abusing the crap out of the battery, but we are putting a draw on it. And what we'll do is we'll see how long it takes to drop the voltage down to 12 volts. If you want to get crazy and really discharge a battery fast, you could use one of these, which is just a 12 volt light bulb array here, and you can see how much current that thing draws. Let me get across it here with this. And that right there is 22.5 amps. So we'll go back to our mild load. I just wanted to show you guys that. So here we are about 8 hours later, and the battery is dropped down to 11.76 volts, which is where we're going to stop discharging. So we're going to go ahead and take our super duper discharge resistor off of here. Set it aside because it's pretty doggone hot. And what we're going to do now is charge our battery back up again using the existing charger, and we're going to check the amount of current that's going to go into this depleted cell here to see if indeed this charger is working. Okay, we just plugged our charger into our discharge cell, and you can see it's putting less than 200 milliamps into the battery, and it's still staying in a low charge rate. It's not going to high rate at all, so we're probably going to go ahead and dispense with this charging arrangement. Now, in disconnecting our existing charger, or the one that's in the booster pack, go ahead and just plug this other one in right now, and we'll see how much current's going to go into it now. As you can see right now, the fast rate, it's putting in 2 amps right now, which is much better than this variety was doing here. Well, we know our charger isn't working correctly, and the AC transformer, you can see how much heat it had at one time, and it basically started to compromise this plastic case because it got so hot at some point. So what we're going to do is we're just going to go ahead and discard the charger that's inside of it. I was going to keep it just to have the LEDs on here, and the LEDs would essentially show me a state of charge of the battery. But instead of having that, I'll just discard with the charger, and for 11 bucks I got one of these digital voltmeters, and I'm just going to go ahead and affix it on top of here. Considering the original charger internal to the booster pack is shot, I'm just going to use one of these right here and basically put some power poles and attach those to the booster pack, and those will also double as an additional output that's similarly equipped in the booster pack itself. And these things are relatively inexpensive. I bought 6 of these at auction some time ago for $30, and of course I had to pay shipping on it, but that was a pretty good deal. And I've already put power poles on these because just about everything I use uses power poles. It's an additional piece of equipment now to charge it off of instead of just being able to plug it in the wall. However, this thing's actually going to cool, because you saw how that original AC transformer had gotten really hot and started to melt its enclosure. And another benefit is I can plug the booster pack into, like this is for my benchtop power supply, I can plug it into a similarly equipped connection hooked to a vehicle's DC electrical system. I can hook it to my charge controller on my solar panel, etc., etc. So it gives the booster pack quite a bit more flexibility in service. So we're going to go ahead and pull our charger board out. I've taken the wire from our voltmeter and I've chased it through, and I'm using servo tape here, which is just a really good quality double-sided tape, and I'm going to attach our voltmeter display on the body of our charger pack here. And the way I'm going to wire it is when I hit this momentary button, it'll tell you the exact state of charge of the booster pack. You can see the modifications we made here. We just basically placed our display in here, chased it through one of the LED holes, used these brackets that supported the printed circuit board, and tied in our red wire to one side of the switch, the second side to our voltmeter, and then taking our ground and picking up this ground sense off of the top of the power outlet, which we can test it right here by just hooking it to a power source. So again, when you just hit the LEDs with the other one, and now this one here is just going to give you the feedback of the current state of charge of the battery. We're going to go ahead and change the battery. This battery is still serviceable. I mean, it's not 100% capacity as we saw. However, you know, this will be useful outside of the pack itself, and since I've got this thing open, I don't want to have to take it apart again. So I decided to get another battery. So I got one of these. PowerSonic is a good gel cell. However, trying to get one that had this tab configuration was difficult. So what I did is I just built adapter terminals here. A couple of standard terminals. You know, standard ones you would get from the automotive store, whatever have you, for these 1/4-inch spades here. And then I got the 1/4-inch lugs. And I've tied them together and I've made a good mechanical bond between them. And then we'll place them on this pack. And the orientation of this battery will be the same. Since I've already got a good mechanical connection, I'm going to make a good electrical connection. And what I'm going to do is I'm just going to flux these. And while they're on the battery itself, I'm going to go ahead and flood them with solder, and that'll make it a good solid electrical connection, and I'll have a good place to tie in my existing connections. And if I do in the future replace this battery pack with something like this, I can either go with making adapters such as this again, or finding this battery here that had the lugs on it. Okay, now we've got the battery installed. We've got the ground together here. And let me zoom in for you here. And you can see I've heat shrunk the connections here for the battery. And I've chased the ground wire back around to the ground side of the battery. And now I'm going to chase the positive side around and tie it in and then heat shrink it. I couldn't insulate the positive side with heat shrink because of the way the cabling lays. Trying to fit all this stuff back together is difficult, but you can see we got our circuit breaker reattached for our cigarette lighter, and we have our wire right here which feeds our voltmeter, and this one here which is our charging wire now for the power pole. Well, here's our booster pack reassembled after we squeezed everything back in there. That's whenever you're taking apart one of these, that's what's important is to pay attention to your cable routing, and if it doesn't feel right, it isn't right, and you need to reevaluate and route the cables correctly inside of it, because you don't want any wires or anything getting pinched internal to something like this. So anyway, you can see we've got our voltmeter on the outside of it, and we've got this momentary button. You hit the button, tells you the state of charge of the battery packs. The LEDs, like I said before, were ambiguous, and the actual state of charge of the booster pack. We have our 12-volt lighter plug on this side here, which is working fine. On the back side, we have our large clamps for jump starting a vehicle. And on this side here, where we had our two connections for our AC adapter that was glued into this plastic piece here, I've just chased out a power pole connection here, which allows me to either, as I said, charge the pack with this, or what I can do is I can hook a device that's equipped with a power pole connector to this to allow it to be powered. Now that we're finished, we can go ahead and put this back in the truck, put it back in service, and it's always nice to have a portable source of 12-volt power. I hope this helps. This is Brett, SurvivalComms. Till next time.